Hello guys, so this is Saral here and I'm welcome back to you the new video of Docker. Today we are going to see that how the new Spring framework has helped us in creating an efficient layering within a single image when we talk it about of Docker image and its efficiency, its division, its distribution of its different layer, segregating your application code base layer with the framework libraries so that once ever you got change your application code base, only that layer will be get worked upon, rest other layers get in cache whenever multiple deployments they do happen. Okay, so before starting, let me introduce myself. If somebody has joined or seeing my video in between, I am Saral Saxena this side, and I have been there on LinkedIn on very active way. I am writing a lot of articles. Go and check out those articles and follow me on LinkedIn, and I am also available on YouTube. Check out my videos. I am continuously posting videos to help you out, guys. Okay, so my today intention it was of telling you that what is coming up new into Spring 2.3.0 milestones, and once it get officially versioned. So what I have learned today is that everything that we are working today is in DevOps environment, and when we say DevOps, we don't want any transitive dependencies that a person or a DevOps person is installing. It's just a single image, it get exploded up and it get working and your environment is ready pack. Okay, so in that case of Spring 2.3 Springboot, sorry, 2.0.3, or in fact 2.3.0 have come up with a lot of interesting features. So first let me tell you, if anyone is new to the world of Docker, that what Docker is used to be. Docker is just a process of creating a Docker file. So normally what we do, this is a simple application uploaded on GitHub, but for your intro let me tell you, there is a simple Docker file. We write this Docker file. It is being commented out. I will tell you the reason. So it's just a simple Spring Boot app which runs on port 8080. Here what we are doing is that we are writing a Docker file. This Docker file will be used when we are using the Docker commands, like when we are building a Docker image. So this Docker file will be get scanned and each line of instruction will be get read. Here we are saying that we want to download OpenJDK 8, we want to add a volume that is called temporary volume, and then we want to expose our application that is being running on port 8080. Whatever is being created jar files in the target folder, they will be get copied into the temp volume and they will be renamed as application.jar. And here we are running simple our application java -jar application.jar by going to that following location. Now the point is that there is a concept called fat jar. Fat jar means, let me show you what these lines of output is going to produce inside a target folder. They are going to produce this three kind of structure. Now the problem is that your application code and your library dependencies, they get tightly coupled and get binded out inside a single folder, and that's how the size of the jar becomes too big. And the second reason is that once you're getting multiple deployments in a day, your one maybe red green or something concept like there, where we say there is a minimum downtime during the deployment. It happens that a jar is being revised, let's say after every quarterly interval of 5 minutes, then the new jar is coming up. So your application changes are there in that new jar, but again other layers like libraries and all the snapshot dependencies are also get tightly coupled back with that jar. So every time you are getting a jar of the same size. So let me open the structure right now. The traditional jar it used to have boot inf. Your classes means your application code and your libraries, they are tightly coupled inside a single folder inside a boot inf, and these are Spring framework libraries. Okay, boot launchers and loader jars. Point is that this is a fat jar. Size of this fat jar is heavy. Any changes that you do in your application is being tightly coupled. Okay, so let me, if you're still not able to explain, I have prepared one document, so I'm going to upload it on GitHub. Here I'm saying that fat jar process is being created as I was showing to you, and this impact the startup time, especially when you are talking about a containerized environment, because the size of your artifacts, your jar is too heavy because it's being tightly coupled. Second, we can save this time by exploding this jar. When I say exploding this jar, it means segregating this things in a one fat jar. You could immediately kept your application code changes inside a sub-nested subfolder, application dependencies inside a sub-nested folder. So every time any changes bring into an application, only that segregated folder is getting changed and is getting packed into the new image, saving the cost, time and caching. Okay, as I told you that Docker images are built-in layer, the nature of Spring Boot fat jars causes application and third-party libraries to put up in a single jar. So that is what is fat jar is all about. When single line of code changes, the entire layer has to be rebuilt. That is I was explaining you. So we need to explode the jar, means we need to unzip, you can say in other words, means we have to segregate the things which are third party, which are your application code and all those. I am showing you the fat traditional jar. It supports Docker images, and this was the frame things that I was supporting you, and these are the things that I've already told you. But now we want to segregate. I wanted to distinguish this structure into more layered format like this, where snapshot dependencies are in a separate folder, libraries are in a separate folder, and application code base is in totally in a separate folders. So this is I am showing you dependency, snapshot, resources. The goal is to segregate the third party libraries into different jar. Code should not be tightly coupled. Whenever your code changes happen, only that particular layer get changed and rest of the layer is get cached. So it brings an efficient Docker image not only during the process or transition, but also when it got to be get deployed. So to order to achieve it, let me show you what I have done. I will be starting with the pom.xml first. All the code is available on GitHub for you guys to further experiment it. I have written a layers tag in it. This means I'm using Spring Boot Maven plugin, okay, to build that jar process, in which I have added a tag called layers. I have added out an instruction called enable true inside it. Okay, there is no further suggestion is coming up, no problem. So I have added the layer of enable true include. So I have added out these layer because I have shown you in the document that I want these layers to be now become the part of the traditional jar. I mean, not this. Earlier it used to be like this fat jar. So to order to achieve this, all these files, you will get the structure like this. So I have already executed this application. So let me show you how the structure that it is going to produce. Here you can see the structure. Now this is going to produce like boot inf classes is separate. There is one file called layer idx which is showing you the dependencies in lib, loader and application dependencies. So this is going to get produced in this way. Okay, now the major part comes is like a Docker file. This Docker file that you are seeing, it's a multi-stage build. It's not a single stage, it's a multi-stage build. Okay, so what I'm doing here is that I'm saying that I wanted to open I wanted to download JDK 11 Slim, means the more compact version. I created a work directory application. I have added the jar files that is there inside the target. So these are my two jar files ending with .jar extension into the target, into the current directory. Okay, I have copies all those jar files, and then I try to run it like this to see whether layers are being there or not. So all the jar files are there, are being copied here, and then I have picked up this hello world REST API jar and I try to extract it and try to see the layers. So this stage I have, this is the first stage, I have given it name as a builder. The second stage which is going to use it will always refer this name, as you can see. Now in the second stage what I'm seeing is that again from the JRE Slim there is a work directory called application. From the builder copy the application dependencies, means application dependencies, all those things try to copy. So let me show you. Here you can see these are application, these are snapshot dependencies. Here you can see the snapshot dependencies. If there are any snapshot dependencies, that is okay. There is your application, means this layer is only your code, that is you are seeing this layer. Now your code, earlier it used to be there in a one single layer, now in that case, but now your application code is inside this layer. So let us see if we can see your application code. Yeah, we can see the same structure. You can see that in this your application code is there. So if you make any changes to this, it will get reflected here, it will be packed into application layer, and only application layer will be get disturbed, not rest layer. will we get disturbed. So that was my intention to show you first of all. Okay, and in terms of dependencies also, you can see that we have different libraries with related to framework now are being kept inside the dependencies. Earlier it used to be under boot inf. Let's see, boot inf, and then it used to be libraries. Okay, now you see it used to be earlier like this, but now there is a separate dependencies is being there. Okay, so you can now see how change it has been taking place. So you have your own different layer of dependencies. Try to take care of this. Okay, this is Docker layer, generated sources. Okay, and so this is my intention to show you out. Okay, so your application have different layer and all these things are differently managed now. Okay, so try to be, I hope you got application layer is segregated, dependencies layer is segregated, it contains all the dependencies, and snapshot dependencies is there. And see, the Spring Boot loader dependencies, cool my man, the Spring Boot loader dependencies are being now segregated. You can see the structure. Earlier it used to be happen to be what, let me show you. Spring Boot dependencies, man, it used to be let me see, it used to be there somewhere, it used to be there like this. Okay, but now you see it used to be Spring Boot loader, now it has to be separate Spring Boot loader layer. So these three layers which I am reflecting you, which I am trying to show you, are being now segregated, and your application layer is segregated. So your application layer will be there. Okay, so let's suppose I have connected, I am running Docker on my IntelliJ. Let me build one more image with a different name, because I have already posted one image. So let me change the name of the snapshot, let me make it as 4. Okay, let me save it and let me try to run this, then it will matter most. IntelliJ, I'm a great fan of this tool. Let me see here, from here itself I am trying to run, just a minute, just a minute, I am trying to run it from here itself. Okay, just a minute, run this option. See, this is started to preparing this right now. Okay, so this is started to preparing this. Let's see how it build that image file. It is reading, preparing building context archive. It is sending the building context to Docker daemon. I have installed my virtual box on my local, and see every step it has done. Okay, it started JDK 11, it is using cache because everything is downloaded on my local. See, at every layer it is using cache, and it is using cache, it is dependencies cache, and then the rest of the layer is of the Spring dependency. Again it is using cache because I haven't done anything, and it is saying that it is successfully built the image, and it is tagged it as a 2.9 latest. So this is the image that it is being seeing, and here can I inspect that image? I can inspect that image, everything is shown. Even I can push it to the my Docker world by tagging it with the 0.3 snapshot. But let me see that I have already pushed one. I don't want to push .3 again because I have already pushed that thing. Just a minute, I have my own public repositories, hello world REST API. So you can see that a day ago, means 0.03 snapshot, I have pushed it up here. Okay, so guys, the only thing that I wanted to show you out from the Docker perspective is that how you can see the things. Okay, it has started also, this application. Let me see the properties. It is showing me environment variables. Okay, it is showing you Java version 11 it is using. Any volume binding? No. Any port binding? No. Any files? Let's see if it is able to bring out those files. Okay, this is the application, and it's being now deployed. I think it's the earlier one, but I will come up with the latest one also, so don't get worried about it. Okay, and so in the meantime you can see this image is being now there. Okay, so you have built a multi-layered image Docker file with the help of Spring by just writing the Docker compose and by using the plugin, as I've shown you Maven plugin, but you have enabled this and you have now got this layered image. Okay, this is the layered image that you have been getting it, and you have pushed that layered image. Right now you can inspect this layered image also. Okay, so it is showing you path, host name, image, working directory was root application. Okay, so as I've told you, working directory, root application, container ID, it is showing, command and everything it is being showing you. Okay, so guys, let me know how do you feel about creating this multi-layered image. I'm going to upload this code on GitHub and this document on GitHub for you. You will get plenty of lot of articles there. So before closing up, thanks for your time, and do follow me on LinkedIn and let me know if I have to come up with more videos. Thank you, thanks for your time. Hope you have loved and enjoyed.